Okay, here we go. This is the first unit presented in the AVP workbook. It's called Venn diagrams and set theory. We'll do lesson 1. You should have received an extra handout for this unit. What I'm going to do is I'm going to go through the examples and the information presented in each lesson, and then I'm going to do like a review section. So I've made up some review notes that just kind of highlight the information that was covered within each of the lessons. Okay, and that'll all be each lesson, and the review will hopefully be within the same video. Okay, so connecting words and, or not. This is what we're looking at today. Here's an overview of the unit. In this unit, we will explore what's called set theory. It's the mathematical study of collections and of objects. We'll be introduced to the connecting words and, or, and not, and their counterparts in set theory eventually. Okay, we'll also work with Venn diagrams and use them to illustrate concepts in set theory, including empty set, disjoint sets, subsets, and universal sets. I'm sure you've had a little bit of experience with Venn diagrams in some other classes. We're going to apply that to mathematics through this unit. Okay, so statements. In mathematics, we deal with statements. A statement is a sentence that has a truth value. It's either true or false. So the value is true or false. A sentence that may be judged by true by one person and false by another is not a statement. It is an opinion. Okay, so look at these following examples. The city of Vancouver is in the province of British Columbia. This statement is true. So this is a fact. The city of Vancouver is on the planet Mars. That is false. So this statement is false. Vancouver is the best place in the world to live. Well, some might think that, some might not think that. This is not a statement. This is an opinion. How do you get to Vancouver? This is not a statement. This is obviously a question. Okay. So example 1. Change my pen. There we go. Determine whether each of the following is a statement. For each statement, list its truth value. The number 4 is a prime number. This is a statement, although it is a false statement, so its truth value is false because 4 is not a prime number. 4 is what we consider what's called a composite number. It's made up of multiplying two other possible numbers, two other numbers together. So 1 times 4 or 2 times 2. If it's only 1 times the number itself, then it is a prime number. Question B, driving in a car is the best mode of transportation. This is not a statement because some people may think it is and some people may think it is not. So this is an opinion. Question C, if you double an odd integer, then you get an even integer. This is a statement. And then maybe you can tell me whether or not you believe that that is true and or false. Not believe, but it's a statement. If you double an odd integer, so an example would be 3. If I double 3, so 3 plus 3 would be equal to 6. This is even. And this can be proven over and over and over again. 2 odds added together would give you an even. So this statement has a truth value of true. Okay, over the page. The negation of a statement is the exact opposite of the statement. So this is using not, okay? The word not is often used to form the negation of a statement. So for instance, one way to write the negation of the statement, the city of Vancouver is in the province of Alberta, is to write the city of Vancouver is not in the province of Alberta. Note that the original statement in this case is false, but the negation of it is true. That's always the case with negation statements. So it says here, in every case where the original statement is true, the negation will be false. Or in every case where the original statement is false, the negation is true. They have opposite truth values. Little note here, it would not be correct to say that the negation of the above statement, like the city of Vancouver is in the province of Saskatchewan, because that's not the opposite of what it was talking about. Both this statement and the original statement are false. The negation must always have the opposite truth value to the original statement. Okay, something to remember. A student made the following false statement. All triangles are isosceles. Which of the following statements below is the negation of that statement? A, all triangles are not isosceles. Not all triangles are isosceles. And all triangles are scalene or equilateral. Okay, so the correct negation of this is B. Not all triangles are isosceles. Okay, so it's all here, so it has to be not all here. Example 3, write the negations of the following statements. A, it is 20 degrees outside. B, it is not Saturday today. I'm going to give you a second. You give those a shot, and I'm going to pause my video for a second. So hopefully you paused your video also, and you were able to take a chance or to see if you can understand this. It is 20 degrees outside. The negation would be it is not 20 degrees outside. Question B, it is not Saturday today. The negation, it would be it is Saturday today. You can see that both the statement, 20 degrees outside, not 20 degrees outside, so both the statement and the negation have opposite truth values. One's true, one's false. Okay? That's always the case. Compound statements. Compound statement is a statement formed by combining two or more statements. The words and or are often used to do that. So for example, it is 20 degrees outside and it is not Saturday today. So there's your and. It is 20 degrees outside or it is not Saturday today are both compound statements. Forming a compound statement using the word and. So a conjunction of two statements can be formed by using the word and. Okay? It's only true, I should use my highlighter. It's only true only if both the original statements are true and it is false otherwise. So both statements in the conjunction have to be true for the overall compound statement to be true. So here's an example. The conjunction of blue is a color with ice is a solid is the statement blue is a color and ice is a solid. It's true because both blue is a color is true and ice is a solid is true. Okay, so both statements in the conjunction have to be true. The conjunction wet is a color with ice is a solid is the statement, sorry, the conjunction of wet is a color with ice is a solid is the statement wet is a color and ice is a solid. This would be a false statement, a false compound statement, because only one of the statements is false, or because only one is true. This one's true, this one's false. So because they're not both true, the overall compound statement is false. And then similarly, wet is a color and ice is a liquid, both of those being false, you would get the compound statement, wet is a color and ice is a liquid. It's false because at least one of the original statements is false. In this case, both are false. Okay. Forming a compound statement using the word or is a little bit different. In English, there's actually two kind of meanings for it. One is what we call inclusive and the other would be exclusive depending on its use. In mathematics though, we are only concerned with the inclusive version of or, which I'll talk about again in a minute here, once we get this under control. So it says in everyday English, we use the word or in two different ways. The following examples will help illustrate this difference. Use of or in everyday English. I here, in order for Drew to have the necessary prerequisites to go to college next term, he needs a pass in grade 12 physics or a pass in grade 12 chemistry this semester. This statement means that Drew will have the necessary prerequisites if he passes physics, or passes chemistry, or passes both physics and chemistry. This is what we call the inclusive use of or. Okay. John asked Helen how she was getting to the school tomorrow. She replied, I will take the bus or drive myself. This means that Helen either takes the bus or she drives herself, but not both. Clearly, she can't take the bus and to drive herself, so not both. This is an example of the inclusive form of or sorry, exclusive use of or. So like I'd mentioned, in math, we're only concerned with the inclusive form of or. So when we make our statements, okay, when we make our statements using or, we have to make sure that we use that inclusive form of or. When we use or, the disjunction of two statements is formed by placing the word or between them. So when we use and, it's called a conjunction. Way up here, and is a conjunction. When we use or, it's called a disjunction. Okay. The disjunction is only false if both statements are false, or true if both statements are true. So the disjunction is true if any of the following happens. The first statement is true, the second statement is true, or both statements are true. Okay, so true if both are true, one is true, doesn't matter which one. Over the page, consider the following statement. I've enrolled a pair of dice, and the sum of the two numbers was an odd number or a prime number. That means that the sum was either odd or prime, or both odd and prime. That's the inclusive use of or. So let's look at example number 4. So example number 4. Consider the natural numbers x that are less than or equal to 15. So something that I'm going to talk about somewhere in some of the notes is if we're talking about natural numbers. Okay, natural numbers are those numbers that include. Natural numbers are those numbers that include. Let's go like this: natural. 1, 2, 3, 4, and so on. Not 0. Okay, so just 1 and up, no decimals, no fractions. Okay, and we usually use the capital letter N to represent those numbers. So if we're talking about the natural numbers x that are less than or equal to 15, we're talking about the numbers 1, 2, 3, all the way through to 15. List the numbers that satisfy each of the following conditions. X is odd. That would be 1, 3, 5, 7, 9, 11, 13, 15. X is prime. So question B, sorry, X is prime. So remember, prime is only divisible by 1 in itself, and 1 is not a prime number. So that would be 2, 3, 5, 7, 9, 11, 13. Question C, X is odd and X is prime. So it has to fit in basically both of those categories. Well, which ones fit in both of those categories? 3, 5, 7, 9, 3, 5, 7. Oh, sorry, I put 9 over here. 9's not prime. 3, 5, 7, 11, and 13. Sorry about that. Yeah, 9 is not prime. You're probably freaking out wondering why I put 9 there. Question D, X is odd or X is prime. So remember, this is the inclusive form of or. So it's either odd, which is all of these, or it's prime, which is all of these. So X is odd or X is prime is that both of those sets combined. So 1, 2, 3, 5, 7, 9, 11, 13, 15. Question E. X is a factor of 3, 5, or 7. So factors, remember, are two numbers that multiply together. So factors of 3, 5, or 7. So this is inclusive. So the factors of 3 are 1 and 3. The factors of 5 are 1 and 5. The factors of 7 are 1 and 7. So we never repeat, although 1 is a factor of all three of these numbers, we never repeat that when we list it out. X is a factor of 3 and 5 and 7. So the only number that was common between the factors of 3, which is 1 and 3, and 5, which is 1 and 5, and 7, 1 and 7, the only one that belongs to 3 and 5 and 7 is the number 1. X is a multiple of 3 or 5 or 7. So within the numbers 1 through 15, the multiples of 3 would be 3, 6, 9, 12, 15. Because it's or, we're including the multiples of 5, which would be 5 and 10 and 15. And the multiples of 7, which would be 7 and 14. So I tried to squeeze all of those together there. So 3, 6, 9, 7, 3, 5. I'm just double checking my answers here. 3, 5, 6, 7, 9, 10, 12, 14, 15. Yeah. And H. X is a multiple of 3 and 5 and 7. So the multiples of 3 were 3, 6, 9, 12, 15. The multiples of 5 were 5, 10, and 15. The multiples of 7 were 7 and 14. What is a multiple of 3 and 5 and 7? Well, there isn't a number that's common between all three of these sets. So we say that number doesn't exist, or we could just say empty set. So now you should be able to take a stab at those questions. But before that, like I'd mentioned, I'm going to, for each lesson, do a little bit of a review of the terminology that we picked up through this lesson. Okay. So we learned about statements. A statement is a sentence that has what we call a truth value. It can either be true or false. If it's true by one person and not true by another person, that is not a statement. It is called an opinion. Negation of a statement is the exact opposite of the statement. Must always have the opposite truth value as the original statement. So if a statement is true, the negation is false. Or vice versa, if a statement is false, the negation is true. It has to be opposite for negations. We talked about compound statements. Compound statements are formed by combining two or more statements, either using and or. Conjunctions are joining two statements using the word and they're only true if both statements are true. So it has to be both. Disjunctions, joining two statements using the word or, and they're true if either statement is true or both statements are true. It's false only if both statements are false. In math, we only use the inclusive. I almost wrote exclusive. We only use the inclusive form of or. Okay? So hopefully that gave you a bit of a quick little background on the beginnings of Venn diagrams and set theory. You have these questions that you should be able to take a stab at. I don't think there was anything that was overly difficult. If you're having questions, if you have any issues or you have questions, you're asking me in class, and we will see you or talk to you in the next video.